Welcome friends to the 18th lecture in module 3 in the online course on health, safety, environmental management practices. We are talking about in this lecture continue to discuss about safety measures in design and operation. This is 18th lecture in module 3, and as we know module 3 is focusing on accident modeling, risk assessment and management. In the last lecture we discussed about some important safety measures in operation. We said that purging is one important mechanism or by safety operation, which is a very common practice in oil and gas industries, essentially which deals with hazardous materials. We are now continuing to look at the factors which affect the efficient way of purging. In that list, let us talk about the time of contact. The duration of contact of surfaces of purged gas and the original gas is an important element. So, the duration of contact of purged gas and the original gas is an important parameter. For better efficiency, it should be minimum as far as possible. For example, if the purge gas input rate is too low, in that case it will result in excessive mixing. By natural diffusion. So, interruptions and variations of the purge gas input rate should be avoided. Okay. So, variations in the input rate of the purge gas should be avoided as far as possible. The other factor which is also important in efficient purging operation, which is safe, is input velocities. Velocity of purge gas at the entrance plays a very vital role. In general, the factors which will lead to this could be size of the inlet of the purge gas, that is a very important parameter. It should be as large as possible. It should be as large as possible and practical. Such that the input velocity should not exceed a specific value. Should not be more than, let us say, a range of 0.6 to 1 meter per second. So, what is the advantage of maintaining the input velocity at this specific range? If the input velocity is maintained at this range, then this keeps the agitation or stirring of the chamber contents at the minimum. So, this keeps agitation of the contents to the minimum. Alternatively, if the input connection or the diameter is too small to the rate of the input, it may result in higher velocity. If the input velocity is higher and output vent is larger, then the purge gas may stream or arc across the inlet outlet, limiting both displacement and dilution. For example, if you have if the input velocity is very high and output vent is very large, then the purge gas will result in a stream of flow. Or what we call arc of flow from the inlet to outlet. So, what is the disadvantage of this? If this happens, this limits the process of displacement and dilution. The next factor which is also important for efficient purging is the density of the gases. The relative densities of the purge gas and air being purged has a very important effect on the mechanics of purging action. For example, if you use carbon dioxide, the specific gravity of approximately 1.5, this will carry the purge gas up to the center or across the chamber. So, let us say if carbon dioxide is used as the purge gas, this shall carry purge gas approximately to the center across the chamber. So, this will result in thorough mixing. Which will improve the efficiency of purging operation. This is large enough when compared to that of a natural gas whose specific gravity is about 0.6, because carbon dioxide has specific gravity approximately 1.5, whereas natural gas has specific gravity approximately 0.6. So, the density of gases in terms of the purge gas and the air or the gas container in the vessel plays a very important role in checking or assessing the efficiency of the purging operation. So, if you have a combination of this order, this will create the inert gases to stratify and remain in a layer at the bottom of the chamber filled with the natural gas. So, one can say if densities vary very far, this will result in stratification. What is stratification? It will form a layer. So, it will remain in the layer, it will remain in the layer at bottom of the chamber, which will be filled with natural gas. Therefore, when purging a light gas out of the chamber, one must say or one must check to push the lighter gas out through the vents in the top of the chamber. So, when one is planning for purging a light gas out of the chamber or a vessel or a container, then one should assess or one should ensure that the lighter gas is pushed through the vent in the top of the chamber by admitting heavier gas at the bottom. Alternatively, when putting back the equipment in service, in that case heavier inert gas is to be replaced by lighter ones. Then the lighter gas should be introduced at the top of the chamber, while the heavier gas is vented from the bottom. When purging facilities out of the service have contained gases with higher specific gravity, then vapors can be effectively replaced with a minimum mixing by introducing an inert gas at the top of the chamber and displace the vapor through the bottom vents. When purging facility into service that are to receive such substances, and after replacement of air by an inert gas, heavy vapors or liquid should be admitted at the base of the vessel, while purge gas should be displaced upwards through the vents. It means the purging cycle and operation is decided based on the density of purging gas and the gas inside the chamber. So, while placing the vessel in operation or placing the vessel out of service, one should be very carefully operating the kind of purge gas with a higher or lower density in comparison to the gas inside the chamber, so that the lighter one is exit out and the heavier one is pushed from the bottom or vice versa. Interestingly, heavier gases like butane, propane or benzyl vapors can be first displaced downwards. Natural gas is displaced upwards because it is lighter out of the top vents by an inert gas, which is subsequently replaced by air. So, therefore, friends, the importance of density difference in purging operation demands approximately about 50% of inert gas is to be replaced by air in a large chamber. So, approximately about 50% of the inert gas is to be replaced by air in a large chamber. If you look at nitrogen as a purge gas, which has specific gravity approximately 0.97, for nitrogen as a purge gas whose specific gravity is approximately 0.97, this is considered to be almost identical to that of air. So that mixing is not restrained by stratification. The advantage is mixing will not be restrained by stratification while the natural gas is being replaced. The next could be temperature effects. It is always advisable to keep the temperature of the purge gas entering a large chamber as low as practical. So, temperature of purge gas entering a large chamber should be kept as low as possible or practical to avoid what we call thermal currents. A positive pressure must be maintained within the chamber being purged, that is another condition. Therefore, friends, whenever there is a sudden drop in atmospheric temperature which can occur during purging of a vessel, it is necessary to reduce the rate of release of the purged gas. That is very important. When there is a sudden drop in the atmospheric temperature, which may cause thermal currents, then one should reduce the rate of release. Purge gas or air, whatever may be the case. Why this is done? Because to offset the contraction of the contents present in the chamber. So, this would avoid offset of contraction, what we call, in the chamber. Please understand that it is not necessary to control the temperature when the chamber is being purged, when the chamber contains solid or liquid. So, temperature control is not necessary during purging operation if the vessel contains solids or liquid. This control is essential only when the vessel contains a gas, because the temperature difference or the thermal gradient will result in what we call thermal currents. Now, let us see what are the special precautions one should take as a safety practice while purging with respect to temperature. The special precaution should be taken if the container or the pipe or the facility contains naphthalene or tar deposits. If the container or the pipe or the vessel contains naphthalene deposits or tar deposits, oil, solvent and other volatile material presence is also a problem. So, one should go for a special precaution when you are purging a vessel or a pipe containing these kinds of hazardous chemicals like naphthalene deposits, tar deposits, oil, solvent and other volatile material. Because they can give off combustible vapors, because they can produce off combustible vapors even under marginal increase in temperature. So, one has got to be very careful and do this with the high level of safety precaution. Either before or during the purging, these deposits like naphthalene etc. should be heated to such a degree that there could be no further volatilization possible during the purging operation. So, one important safety measure when you are purging vessels or pipes having these kind of deposits is to heat the container such that no further vaporization is possible. So, this is what we call as, this is called as topping distillation of deposits. This may be required in the following cases. One, steaming of the chamber or system prior to gas and purging. So that you avoid further vaporization, that is what we call as topping distillation of deposits. You can also alternatively use steam as the purging gas. That can be an advantage, and this will not allow any further vaporization. The third method by which a safety measure can be adopted is admit the purge gas at an elevated temperature saturated with water vapor Now, the question comes, what are those factors which can be considered to obtain high mechanical efficiency during purging? Factors considered to improve mechanical efficiency during purging. We all know that purging necessarily activates mixing and dilution. To make it efficient, one can follow the following procedures: avoid interruptions, or variations in purge gas input, so the purge gas input should be more or less continuous and constant. Second could be use large input connections, so that the input velocity is more or less controlled. That is the third point. So, control input velocity. Fourth could be introduce purging gas at a proper location with respect to gas density. because we already saw that if the gas density inside is lighter, then we should push the gas to the exit by pumping the purge gas from the bottom and vice versa. So, introduce the input purge gas at a proper location, either from the bottom or from the top or from one end, push to the purge gas to the other end, etc., so that you make a proper and ensure a proper mixing of the purge gas with that of the vapor or the gas present inside the chamber. Other idea could be avoid differences and sharp changes in temperature. So that thermal currents can be avoided. How this can be achieved? Use larger vents, so that ready escape of displaced gas is possible. So, with this in mind, after understanding different factors which can influence the purging operation and what are those safety precautions which should be taken care of to ensure proper mixing and dilution during purging operation, let us try to understand now with this perspective different methods of purging. We already saw different methods of purging in terms of what should be the inlet and outlet pressure control, whether pressure control or pressure purging will follow vacuum purging, etc. We also saw the quantity of gas required for such kind of purging operations or purging methods. We will once again look at the method of purging in a different perspective, because now we have more information about the factors that can affect or efficiency of the purging operation together. Method of purging, let us say a revisit, we want to once again look into this. There are many methods of purging that are commonly practiced in process industries. Broadly, there are two types: batch purging and continuous purging. Broadly, there are two types. One is called batch purging, other is continuous purging. So, let us say common methods of purging which is practiced in oil and gas industry. Let us start with siphon purging. In this method, equipment that is to be purged is filled with liquid. Purged gas is introduced into the vapor space to replace the liquid. Which is then drained from the equipment. Liquid is subsequently drained from the vent of the equipment. In this case, the volume of purge gas required for operation will be equal to the volume of the vessel. rate of application will be as same as that of rate of draining. Okay. The next is vacuum purging. In this method, equipment that normally operates at reduced pressure or equipment which is capable of operating reduced pressure is purged using vacuum purging. So, the primary requirement is that the equipment should be capable of operating at reduced pressure. Then only one can go for vacuum purging. In this case, purging is done by shutdown or during the shutdown. During the shutdown by breaking the vacuum with the purge gas. With the purge gas. If the initial pressure is not low enough to ensure desired low oxygen concentration, then it is necessary to re-evacuate and repeat the process. That is why in case of vacuum purging you need to do more cycles. So, if the initial pressure is not lower enough to ensure desired low oxygen concentration, then the cycle is repeated. Okay. Amount of purge gas required in this case is determined by the number of applications and number of cycles. By the number of applications or let us say number of cycles required to develop the desired oxygen concentration. If you are talking about purging parallelly 2 or more containers which are joined by a manifold, in that case purging is done as a group. Then the vapor content of each container should be checked for completeness of purging. Okay, that is very important. The next could be pressure purging. In this method, enclosures might be purged by increasing the pressure within the enclosure. This is carried out by introducing the purging gas under pressure. After the gas is diffused, the enclosure is vented out to the atmosphere. In this case, more than one pressure cycle may be necessary, as we saw in the last few lectures back, because this is helpful to reduce oxygen concentration to the desired percentage. So, purging is done under pressure or purge gas is allowed inside the vessel under pressure many cycles may be again required to achieve the desired oxygen concentration. When two or more containers or tanks are to be purged in parallel or when they are joined by a manifold, and if they need to be purged together as a group, then the vapor content of each container should be checked so that the desired purging pressure is achieved. When a container filled with combustible material is emptied and then purged, so that is very important. If a container has combustible material then it should be emptied and then purged. Okay. In that case, purge gas is applied to the vapor space at pressure consistent with equipment design and limitations. Emptying of the vessel and the purging of vapor space should be done in parallel, that is very important. So, emptying of the vessel and purging operation should be done in parallel. That is important. Sweep through purging this method actually involves introducing a purging gas into the equipment at one opening and letting the enclosure content to escape to the atmosphere through the other opening. So, inlet the purge gas at one end and let the vapor or the gas inside to escape through the other opening. That is why it is called sweep through purging. Purging gas sweeps through the container, okay, through the container. In this case, the quantity of purge gas required depends upon the physical arrangement you have. Pipelines can be effectively purged with a little amount of purge gas, a volume of purge gas, if the gas can be introduced at one end and the exit can be taken away or the mixture can be taken away at the other end, and both operations happen in parallel. So, friends, in this lecture we understood what are the factors individually which affects the purging efficiency. To make purging safe, which is one of the important vital requirements in oil and gas industries, what are the factors and precautions one need to consider while purging operation is being carried out? What are different methods of purging which is now revisited with a better understanding in terms of safety practices? We will continue with this in the next class as well before we move on to further safety practices as applicable to HSE in terms of oil and gas industries. Thank you.